calculus. We're going to start 4.5 right now, U-substitution for integrals. I've given you a 5-step process of being able to use U-substitution when you want to integrate a question. And I'm going to work through that example problem over there and show you how each one of these steps is effective. So the first thing we're going to do is we're going to pick our u value, which is some function of x, and we're going to do that in such a way that the derivative of u, which is the derivative of that function of x we're picking, appears in the integrand exactly or is off by perhaps a constant multiple. Now this particular example I've made up is going to work perfectly because what we're going to see is our du is going to be sitting inside our integrand exactly. So I'm looking at the integral of x squared plus 1 quantity to the 50th multiplied by 2x dx. I'm hoping that you see that if I let u equal x squared plus 1, the derivative of x squared plus 1 is sitting right here, 2x dx. And that's exactly what I'm going to do. Once you notice that, you're good and you're set for the rest of the time, I would imagine. Let u equal, we're going to go ahead and write x squared plus 1. And then what happens is we typically would write du dx is equal to 2x, but we're going to change our format just a little bit, and we're just going to say du equals 2x dx. So the derivative of u is equal to 2x with respect to x. Okay? This is going to be the du part, and it's sitting right here. So I would like for everybody, when they find this extra piece that's sitting right here in their integrand, that they circle this, and that quantity right there matches du. So I'm going to write du right above it. My u was x squared plus 1. So over here, where x squared plus 1 is, I'm going to put u. And now I'm going to be able to rewrite this all in terms of u. This is going to end up being the integral of u to the, that's still an exponent, 50, and then plain old du. So let's see where we are up here. We picked our function u, which is a function of x, such that the derivative of the thing we chose for u is sitting right in the integrand exactly. So the derivative of x squared plus 1 is 2x. Now, make the substitution for u with whatever function of x you chose, and du as the derivative of that function with respect to x. Now, in parentheses, it says this may involve multiplying by a constant, and that'll be in a future example. So at this point, we should have no x's left at this point in the game. If so, we got to go back to step 1 because something else went wrong, and we got to go back and rethink our process that we started with. We have no combination of u's and x's. This right here is all u and u, no x's in here. Okay, now we're going to integrate with respect to u. That turns out to be a simple power rule. So we're looking at u to the 51st divided by 51. Let's not forget our constant of integration. And now, for the very last, step 4 anyway, not the very last thing, we're going to replace the u in terms of x. So my u was x squared plus 1, that's got to come back into the problem. X squared plus 1, quantity to the 51st, over 51, and then plus c. This is going to be my answer. And what I need to do now for my very last step is just a check, okay? Just a simple check to make sure that you convince yourself you have the right thing. We're going to take the derivative of our answer and make sure that we get right back to our integrand. And we can do that by working things out a little bit in detail. Matter of fact, I think I will right here. Let's just go, this is my check. I'm going to take the derivative with respect to x of this thing I boxed, x squared plus 1, quantity to the 51 over 51 plus c. And I'm going to take this derivative with respect to x. The 51 will come down, this is a power rule, 51 will come down, be a multiple outside of your x squared plus 1. I have to subtract 1 from my exponent, so that's going to bring me down to a 50. And then I have to chase this with the chain rule of the derivative of my oogie boogie is what I call this. So x squared plus 1, the derivative of that would be 2x. And I need to also remember that I'm still over 51. I take this derivative of plus c and that turns to nothing. So my 51s are going to divide off. I'm going to end up having this thing right here, which was indeed exactly what was sitting inside my integral. minus the dx, but that's okay. Because this part right here, this x squared plus 1, quantity to the 50th times 2x, that's called my integrand. All right? And then this tells us what we're integrating with respect to. So I just need to get back to x squared plus 1 to the 50th times 2x, and I did, so this checks off, and I'm good to go. All right, I'm going to give you a second example, and we're going to follow right through everything we already did. Hopefully make it a little more complex. Let's see what we have here for number 2. Okay, I am looking at example 2 being the integral of x times 3 plus x squared quantity cubed with respect to x. Now you just have to glance at this. These typically aren't that hard, and plus I see some parentheses here with a quantity cubed. Chances are whatever's in the parentheses is going to be my U-substitution, and if it's not, we'll see. There's other ways that we can attack the situation. But right here, if I were to take the derivative of 3 plus x squared, I would get a 2x. Well, I don't have a 2x sitting here, but I do have x sitting here. And that means that I'm off by a constant, and that constant would be my 2. So let's go to the side, and we're going to let u equal 3 plus x squared. My du therefore becomes 2x dx. Now I don't have 2x dx, I have x dx. And you know, if it helps you, maybe it would be a good idea to rewrite this so that the x dx is sitting on the right hand side and the x and the dx aren't split apart from each other. But pretty soon you'll be able to connect those in your mind and not do that particular step. So I'm looking at a 2x dx, but here I only have x dx. So I'm going to divide by 2 here so that I can have just x dx. All I need is the derivative over here to match this. And this gives me 1/2 du. So here's my x dx, here's my x dx, and this is 1/2 du. What's in the parentheses here is my u. So I may rewrite this now as u cubed times 1/2 du. So far, I've chosen my u as a function of x, and it turns out that the function of x is 3 plus x squared. So this is like the g of x in the steps. And then I'm looking to make sure that my du, which is the first derivative of this function right here, appears in the integrand exactly or is off by a constant multiple. We said that this derivative was going to be 2x dx, and 2x dx doesn't appear exactly in my integrand, but it's off by a constant multiple. So I'm looking at my constant multiple being a 2. I'm off by 2. I'll counteract that 2 by dividing both of these by 2, and I'll have 1/2 du equals x dx. Circle the x dx, replace it with the 1/2 du. Remember here, make the substitution of u as your function of x, which we're doing right here when we say u cubed. I am making that substitution of u as my function of x, okay? And my du, so whatever the derivative is over here, make sure I can replace it with du or some constant multiple of du, which was 1/2. I'm just rewriting it as 1/2 du right there. All x's are absorbed. There are no x's at this point. Everything here is in terms of u. There are no x's. So I'm good now to integrate with respect to u. So I'm going to take this 1/2 to the outside of my integral, and I'm going to integrate u cubed with respect to u. So that's 1/2 u to the 4th over 4 plus my constant. So I can separate that a little, put that together a little bit, and just call it u to the 4th over 2 times 4, giving me 8 plus c. Now I need to replace my u in terms of x, so whatever I have my u is 3 plus x squared. I now put 3 plus x squared, quantity to the 4th, over 8 still, plus c. And this is the answer to my problem. I now should check this and see whether or not, if I take the derivative with respect to x of all this, 3 plus x squared, quantity to the 4th over 8 plus c, whether or not I do indeed come right back to x times 3 plus x squared, quantity cubed. Hopefully I will. The 4 will come down, quantity 3 plus x squared to the 3rd, chase it with the chain rule of 2x, still divided by the 8, and then plus nothing on the end for my constant. The derivative of any constant is 0, so that's there. I have 4 times 2, make an 8, so the 4 and the 2 together will divide off with the 8, and I am indeed left with x times 3 plus x squared quantity cubed. This does indeed check. And I'm going to end our video with those 2 examples, and we'll come back on the next video with a few more examples. All right? Talon out.